All right, good morning, class. So now we're going to talk about volume. Now, it may seem a little overwhelming at first, but the key is first you need to identify the shape to know what formula to use. But as you'll be looking through your packet that I provided you, mind you, we're not going through all those problems. I crossed out some. So don't feel overwhelmed looking at it. But we're going to simply be find the volume of each figure, and using the formula that's provided, we just plug it in and solve. Okay? So a little intro, which I feel a lot of you all are accustomed to or recall. For rectangular prisms, like a box of cereal or an Amazon Prime box, you do length times width times height. Now, you can identify what is the length, what's specifically the width and the height, but since you're multiplying them all together, it doesn't matter which number you put for length, width, or height, because if you multiply those three together, you're still going to get the same answer. So, for number one, actually, you know what? For one, I'll do one and you do two and three. So number one, if I wanted to be picky, which I don't mind if you do not, I see that there's the length is 17, the width is 9, and the height is 24. So I multiply them all together to get the volume. Notice if I switch them and I multiply, I'm going to get the same answer. Now, when you multiply them together, you will get a large number, 3,672 centimeters cubed. Okay, it's cubed because this is 3D. This is three-dimensional. We multiplied a length, a width, and a height. 3 letters. 3 variables means it is cubed because it's three-dimensional. If we were finding the area of this flat surface, area would be length and width. Length times width is two-dimensional. A flat surface is 2. But when I multiply by 3 variables, it's now three-dimensional. So it's cubed, not squared. All right? So with that, I will pause this video and then have you try out 2 and 3 and see what you get. All right, now, for number 2, you would have gotten 630 inches cubed because you would do 10 times 14 times 4.5. Number 3, you would get 3,744 feet cubed. Because I have, depends on how you look at it, but to me I see a length, a width, and no, actually this would be the width, that'd be the height, but you'd still get the same answer. Okay, so that's an introduction about volume. So now let's look at something a little different. Now this one, pay attention carefully to. It's a little different to wrap your mind around. Okay, but let's go over it. So, all other prisms. Well, nice thing, we're not going to talk about trapezoidal prisms. Don't need to. If we were going over material for the EOC, it's not on there. So I wouldn't have taught it to you anyway. But I have a triangular prism because prisms, I see a triangle here that is parallel to another triangle in the background. Those two triangles that are parallel tell me it's a triangular prism. Now, notice we have volume equals capital B times H. It's not just little lowercase b like we're used to, base times height. Here, capital B is the area of the base. So think of B as bottom. What is, and I don't mean the bottom like here in number 5. It means what's the area of the parallel bases, which are triangles. Number 4, I understand, is very confusing how to pull the material out, but when I have you try 5, I think it'll be more simple compared to number 4. So number 4, it says, okay, capital B, I need the area of the base. So what I like to do is say, okay, I first want to identify my capital B. Well, my capital B is a triangle. The area of a triangle is 1/2 base times height. So notice now we have a little b that we're used to. So see how we have this dotted line here forming a right angle to this line right here? Whenever you see this right angle, it's perpendicular to the base, bottom, then I see that I have nothing here, but if I look parallel, like a parallelogram, I can see that this is 12 feet. So I have 1/2 times 12, and then the height of the triangle, so maybe if you wanted to do capital B of a triangle, so you know it's the triangle you're looking at, the height is the altitude, or what created the right angle, which is 7.3 feet. Okay, I would calculate this. 1/2 of 12 is 6. 6 times 7.3 is 43.8. So my capital B is 43.8. So I have the capital B down. Now when it says height, notice it says height between the bases. So if this is my triangle here, and here's the other triangle in the background, it's asking, okay, what's the height between? What's the space between this triangle to the other triangle in blue, from here to here? And notice the distance between those two triangles is 5 feet. So the height is 5 feet. So now I have everything I need to find the volume now. My volume is capital B, which we found to calculate it to be 43.8, times the height, the distance or the height between the two bases in blue, which is 5. And we get 219 feet cubed. And the reason for that is we did, for the area of a triangle, you had base times height, 2 letters, times the height between the bases makes it 3. So it's 3-dimensional volume, the amount that fills up. Or if I poured water into this, how much can I fill? It's volume. Okay, so breathe. I want you to try number 5. Find the area of the base, which here I can see that there's 2 triangles parallel to each other, so it's just like how we did number 4, but I think the numbers are easier to pull out to see what we need. So find the area of the base, find the height between the bases, and then get your volume. Okay, so I'm going to pause it and have you try it. Okay, now, I'll tell you about it later. So, for this, my capital B is 1/2 the base, the bottom of this triangle, it's like facing towards me. Here, I'll highlight it in black marker. So the base is 11. How tall it is, because I see the right angle, is 5.4. And that gives you 29.7. The height between the 2 triangles, see right here is between the 2 triangles, is 16. So my volume is 29.7 times 16, and you should have gotten 475.2, there's a 2 there, okay, you can see it, 2 millimeters cubed. Okay? All right, now, see if I did this one correctly. I think I had your worksheet a little scrambled. Let me make sure I have that. Okay, so now, since we're talking about capital B and getting accustomed to capital B, let's continue with that. Let's continue. So, if we look at pyramids, notice that if I were to do this, watch what I do. I know I'm not the best artist, but notice that this makes what? What does that make? It's a rectangular prism. We're not for sure if it's a square, so we'll say it's a rectangular prism. And it would be length times width times height. Well, if I take 1/3 of that, I get a pyramid. If I take 1/3 of length times width times height, I get a pyramid. Okay? So, find the volume of each pyramid below. Okay. So first off, I am going to let you know that, which one was it? Yay or nay, yay or nay. Yeah, I think we should still talk about it. I'll see how I feel. Oh, actually, no. Cross out number 6. Don't even worry about number 6. Okay, so for pyramids, let's first take care of this capital B. Well, the base, this time the base is the bottom of a pyramid. When we had triangular prisms, we were looking at what sides were parallel to each other. That was their base. Here we're actually talking about the bottom, what's touching the ground. So here, the base, you almost think it's a square, but it's a little off. But you'd still do length times width, which is 10 times 11, which gives you what? What does it give you? 110. And then we need the height. How tall is the pyramid? Well, they're so nice they gave it to us. The height, its arrow is pointing to the right angle. It is 16. So my volume is, don't forget, 1/3 times capital B is 110 times the height of the whole pyramid is 16. And when you multiply that all together, you get about, and I'll say round to the 10th place. 10th place, we would get 586.7 inches cubed. Okay? So, I want you to try out number 2. So I'm going to pause it and have you try it out. All right, now I'm going to do it this way and just try something a little different. It'll also save us time. So here, you should have gotten 315 yards cubed. Length times width times the height of the pyramid. The length and width is your capital B, the area of the base, which is a rectangle, times the height to stretch it at a point is 5 yards. Okay? Now something that may also happen, Bless you, Marvin. Sorry, that was my cat. If you look at number 3, I do see it's a square. So I have my length and width, but notice this is not the height of the pyramid. That's on a slant. It's like on one of the faces. We need this height. I drew like a right angle. I know it's hard to see with my marker because it's a thick marker. Well, to do that, if I drop an altitude, recall that the altitude cuts this length in half. So if this is 14, my altitude now cuts it in half to where I have 7. I need the height. I'll put X there. But the slant, keyword slant, I have my hypotenuse. So guess what? It goes to Pythagorean theorem to find the height of the pyramid, to then find the volume. So if I go over here, so a squared, so one of the legs is 7. We need to find the height, that's the other leg. You could put x squared or b squared equals 25 squared. If you square everything, 25 squared, I think that's 625. Good thing I got my calculator. I want to make sure I'm right. Oh, I'm good. 625. Subtract 49 over, and you get x squared equals 576. Well, what's the opposite of squaring? Square root. So now I do the square root of 576, and I get 24. So I now know that the height of this pyramid is 24. So the height is 24. I'll do a slash. Our capital B is length times width, so 14 times 14, or 14 squared, which 14 squared is 196. So now I have everything I need. They may throw this curveball at you once in a while, but not often. So the volume is 1/3 times my capital B, 196, times the height, which we had to find using Pythagorean theorem. And what you get is, yes, I might be using my key, is 1,568 feet cubed. Okay? Again, doesn't happen often, but it might. So, what I'd like you to do is I would like you to try number 4. Hint, no Pythagorean theorem needed. And I would like you to try number 5 as well, but Pythagorean theorem is going to be needed. Okay, so try out 4 first, and then we'll go to 5, and Pythagorean theorem will be involved. So give that a whirl. All right, now for number 4, you would have gotten, you have your base is 12, the height is 7.5, and it's a triangle this time. I wanted to see if you catch that. The bottom is a triangle, so it's half base times height. Base is 12, height is 7.5. Okay? And then how tall the whole pyramid is 10. So you still take 1/3. It's just now the capital B was the area of a triangle times how tall the pyramid is, which is 10. You get 150. Okay? So I want you now to, if you haven't yet, try out number 5. Hint, Pythagorean theorem is going to be needed to find something. All right, now, using Pythagorean theorem, you would see that, and I don't want to use this, I'll use a highlighter. We do have the base, but we need the height of the triangle at the bottom. See how we have the base, the bottom, but we need the height of a triangle. Half base times height. So you use Pythagorean theorem. It's a leg, so x squared plus 14 squared equals hypotenuse squared. Get x by itself and square root 17.1. So 1/2 base times height gives me my capital B. And how tall the pyramid is 19 meters. So 1/3 times capital B times the height of the pyramid. 758.1 meters cubed. Okay. All right. Now, let us make sure I'm going in the right order. Yes, I am. Number 7, I will just let you know. Notice it's going back to Prisms. I copied it wrong when I was scanning. Number 7 is another scenario. So number 7, oh good grief. Number 7 is a triangular prism, and the capital B is the area of a triangle. 1/2 base times height. Well, I have the height, it's 28, but I don't have the base. But if I look at this ramp parallel, it's 32.5. So I need to use Pythagorean theorem to get the base of my blue triangle. So it'd be x squared plus 28 squared equals 32.5 squared. Excuse me. And then you'd see that the base or bottom of the blue triangle is 16.5. So then you have 1/2 base times height, capital B, done. And then remember, the height of a triangular prism is the distance between the triangles, which is 31. Okay, so I'll pause this so you can write this down. I think I'm even going to, if I can get a pen, I'll write down right here that you also need to do 28 squared plus x squared equals 32.5 squared. And then you'd solve for x and get that x equals 16.5. Okay, so I'll pause this so you can write this down as your notes, because you never know on your homework. Okay, now let us continue on. Take a deep breath and let's do something that isn't too mind-boggling. I know the capital B can throw you off, I understand. Now, next one is cylinders. Cylinders, the volume is pi r squared. Pi r squared. That's the area of a circle. Notice we have 2 circles parallel to each other. So it's kind of like capital B. So they're doing pi r squared, the area of a circle, times the height, so they stretch it to make it 3-dimensional. Let's apply it here. Number 9. So volume equals, and you can use 3.14 in place of pi, but perhaps my answer key is using the pi button. So if yours is very close to my answer, then you are fine. Okay, so here I have pi, or 3.14. Well, I'm just going to say 3.14 according to my, pi according to my key, but 3.14 is fine in your calculator. R, the radius. Well, what's the radius of this? Well, backtrack. Radius is the center to a point on the circle. So here they gave us the radius. They're so sweet. So it's 18 squared times the height. How tall is that? I don't know, can of tuna. And it is 15. So 15 times 18 squared times, I'll use the pi button, but it is perfectly fine if you use 3.14. You would get 15,268 point, I believe 1, if I'm rounding it right, inches cubed. We'll keep rounding to the tenths. Okay, and that is it. You have to identify the radius, the height, times pi. Make sure you do squared, I'm sorry, radius squared, times pi, and you have your volume. Okay, try out number 10. All right, number 10. For number 10, this time they gave you the diameter. If the diameter is 11, to get the radius, I take half the diameter. So half of 11 is 5.5. So they put 5.5 for the radius. From circle to circle, from the parallel bases, there's a height of 21. It's like a toilet paper roll. It's 21 meters. So you do pi times radius squared times height, and we get 1,995.7 cubic meters. If you use 3.14, it should be pretty darn close to this, and you are perfectly fine. I'll accept either. Sorry, my cat needs loving, or else he's gonna jump up here and go crazy. We'll see what happens. Okay, so, no, not right now, buddy. Go on. Go on. Yep, we'll talk later. Okay, so that is what I wanted to talk about that. Next, and I need to, I believe, put the next paper in. I didn't bring enough of these page protectors home, unfortunately. Let's see here. Where is it? That one here it is. All right. So let's talk about cones. And this is a good segue, actually. We just talked about cylinders, which was pi r squared height. So here we have a cylinder. So remember when we took a third of a prism, we got a pyramid. If I take a third of a cone, so if I take a third of it, sorry, a third of the cylinder, I get a cone. So now the only thing we're doing is we're adding 1/3 in front. So for example, number 7, volume equals 1/3 pi. They give us the radius, which is 9, so 9 squared. And then the height. So kind of think of like an ice cream cone, and how deep does it go to put ice cream in it. Always look for that lovely right angle. If you see a right angle, it's perpendicular. That's also telling me a height. And how deep it is, which is the height, is 17. So if I do 9 squared times 17 times pi, and then divide by 3, or times it by 1/3, either way, you will get 1,441, and it's 0.99, but I said round to the tenths place, so it would actually be about 1,442.0 yards cubed. Okay, and that's it. Number 8, identify the radius, and I want you to find the volume. All right, so you would have gotten 1/3 times pi times 2.5. They did it to us again. They gave us diameter Half of 5 is the radius, which is 2.5, so pi radius squared. And the height, even though it's slanted, how deep? It is 8. So if you multiply those all together, you get about 52.4 inches cubed. Okay? All right. Now, if we look at number 9. Number 9, okay, so volume is 1/3 pi. This time I see they gave us diameter again. So half of 27 is 10, 12, 13.5. Because we took half the diameter. And then we need the height of the cone. This is the height, but they didn't give it to us. But guess what comes back? If the radius is 13.5, and we have the hypotenuse, 22.5, we can find the height, we'll call it x, by using what? Pythagorean theorem. So, it would be x squared plus my other leg, 13.5 squared, and I ran out of space, equals 22.5 squared. Okay, so when we square everything, subtract the leg over to the hypotenuse to get x by itself, okay, and take the square root, we would find that the height of the cone is 18. Okay, so you'd square everything, subtract that number over from the hypotenuse, so you'd have x squared equals a number. Well, the opposite of squaring is square root, and you'd get 18. So then we can finish off this problem. So 1/3 times pi times 13.5 times 18, had to use Pythagorean theorem. You do get a large number, 3,435.3 kilometers cubed. All right, so yes, it does weave in. As we've been building in all these units, they tie things in together. So in Unit 4, they're tying in something from Unit 3, Pythagorean theorem. It doesn't go away, okay? Now, if we had time, I'd love to go over applications, but because of our scenario, what we're having to deal with, we're gonna skip that. I just wanna go over the fundamentals. Okay, now, I believe this is the last page. For the most part, yes it is. Okay, last thing is spheres. The only thing that's different every time is the shape. We keep using the volume formula and plugging in what we know to get the answer. Now recap, parts of a sphere. Now from this dot to, so if I look at the circle, let's look at this circle in here. Center to a point on the circle, radius. This line, this arrow is pointing to this entire line. That's the diameter. Bottom left, it's pointing at the center. That point, that's the center. And then this here is actually pointing to the circle I highlighted in black, and that's called the great circle. I'll just do a circle for short. The great circle is what slices the sphere into 2 hemispheres. So think about the globe. The globe is a sphere, and then if you slice it in half, That great circle then opens your globe into 2 hemispheres, okay? So just keep that in mind. We'll get to that in a little bit. Okay, so volume of a sphere is 4/3 pi r cubed. Notice it's radius cubed, so it's radius times radius times radius. It's still 3-dimensional. It's still going to be volume. That's what makes it volume. It's 3D. So here, volume equals 4/3 pi, and here the radius they give to us, which is 7, cubed. So if you do 4/3 times pi times 7 cubed, you get, remember I'm using the pi button here. It's okay if you use 3.14. So 1,436.8 inches cubed. Okay, and that's it. That's all there is to it. It's about identifying the shape, locating your formula, and plugging in what you find and what you know. So number 1, they gave us the radius. Number 2, this 33 is at the center. So that's telling me the diameter is 33. So therefore, the radius, we have to take half of 33, and you get 16.5. So now we have everything we need. But it's going back to knowing the parts of a circle and how to go from diameter to radius and radius to a diameter. So volume equals 4/3 pi times 16.5 cubed, because we had to take half of 33. And you would get 18,816.6 centimeters cubed. Okay, boom. Now, number 3 and 4, I want you to try and find the volume of those. 3 and 4, find the volume. Give it a try. All right, now, for here, notice I crossed out surface area and put volume because this was an integrated part where they taught both, but I decided it'd be good practice. So, if we have 4/3 times pi, where's my pi button? I'll do times 3.14 just because I don't want to keep you waiting. So 4/3 times pi times, they gave us the radius, cubed. And let me know if I did it wrong, but I got, using 3.14, so I'll put it here. I used 3.14 this time. Volume is 91.9 meters cubed. For number 4, they gave us the diameter because the 24 is in the center. So the radius is half of 24, which is 12. So now I go by my formula. 4/3 times 3.14 times 12 cubed, and we get a volume of 7,234.6 millimeters cubed. Okay? Now, the last thing are hemispheres. It looks like a bowl. Instead of a sphere, we have a hemisphere. Now, they give you the formula here. And the reason why it's now 2/3, well, here it was 4/3 for a sphere, right? Well, what's half of 4? Like we take half of a sphere as a hemisphere. What's half of 4? 2. So now it's 2/3 pi r cubed. 2/3 pi r cubed. So here it's volume equals 2/3 pi. Let's see, center to a point on the circle, they gave us the radius, 5 cubed. And I'm using pi this time. I get 2,000, oh not 2,000, I'm sorry, 261.8 kilometers cubed. Okay. Another way you could do it is you could use this route. You could do the volume of a sphere, so do 4/3 pi times 5 cubed. But that's a sphere, so whatever your answer is, you would then cut it in half, and you'd still get this answer. Either way works. Either way. All right. We are just about there. So what I want you to do is I want you to try the last 3. Work on 6 through 8. Try it out on 6 through 8, and we'll call it a day. Okay, so try these out. It's your choice if you want to use pi or 3.14. Okay. Now, I guess I could have just done it this way. But I'm going to have you check your answers. So, number 6, it was diameter is 18, so half of 18, I get a radius of 9. Get an answer of 1,526.8 feet cubed. Number 7, it says surface area, but I want you to find volume. Number 7, oh snap, it's not going to have the correct answer. Oh, I almost did so well. All right, so I had to go back to this anyway. So that was the answer for 6. Number 7 is 2/3, I'll use 3.14 this time, times, they gave us the radius, that's the center to any point on the circle. In this case, it's on the sphere, times 14 cubed. You get 5,744.1 yards cubed. For number 8, we have to take half of 12.2 because that's the diameter, so 6.1. So if I do 2/3 times 3.14 times 6.1 cubed, you get 475 point. If we do technical rounding, it could be argued that it's 0.2, but if you had 0.1, I understand. Okay, and there we have it. So that is about volume. Okay. Next week, we're going to go backwards. They're going to tell us the volume, and they want us to find the height or a radius. So then we're going backwards, which involves algebra. But let's first focus and make sure we can get a handle on this. Okay? After this video, I will let you know what your homework is.